Liam is back in the hot seat today. Take it from here.
Appreciate that, Erica. Okay, I have a study approach for this that really helped me. Let me share. Threat modeling is one of those topics that ties directly into everything we have covered in Domain 1: risk identification, control selection, governance. If you understand risk management, you are halfway to understanding threat modeling. Today, we make that connection concrete.
Welcome back, everyone. Threat modeling is the structured practice of identifying what can go wrong in a system before attackers do. It asks 3 deceptively simple questions. What are we building? What can go wrong? And what do we do about it?
Strip away all the jargon, and the answer is simple. Threat modeling is how you think like an attacker before an attacker thinks about you.
Think of it like an architect reviewing blueprints before a single brick is laid. It is far cheaper to move a load-bearing wall on paper than after the building is standing. In security, that same principle applies. Fixing a design flaw in threat modeling costs a fraction of fixing it post-deployment.
This subtopic sits in Domain 1 because threat modeling is fundamentally a risk management discipline, and research shows fixing a security flaw at design costs roughly 30 times less than fixing it post-deployment. We will cover STRIDE, PASTA, VAST, attack trees, the kill chain, and data flow diagrams. Stick around the trust boundary section in Scene 5 changes how you think about network architecture. Here is who is with me today.
I am excited to watch this one unfold. I will jump in when I cannot help myself.
Isabella here, really glad to be digging into this with everyone.
Hey, I'm Michael. Honestly, I am hyped for this one.
Great team, let us get into it.
STRIDE is 6 threat categories, 1 acronym, and the most widely tested threat modeling framework on the CISSP exam. Microsoft engineers Lauren Kohnfelder and Prarit Garg published it in 1999, and it has been the industry reference ever since.
Spoofing is the S an attacker claims to be someone or something they are not. Think IP spoofing, forged email headers, or stolen session cookies. The countermeasure is authentication. Verify the identity claim before trusting it.
Tampering, the T, is unauthorized modification. Think of a river with a current. The data should only flow one direction, untouched. An attacker who reroutes or alters that flow mid-transit has tampered. Integrity controls hashing, digital signatures. Checksums are the countermeasure.
Repudiation, the R, is the threat of deniability. If a user can delete their own logs, they can deny they ever executed a transaction. This trips up candidates who have been doing this for years. The countermeasure is non-repudiation through audit logs, digital signatures, and timestamping.
Information disclosure connects back to what we covered in the CIA Triad episode, confidentiality failures. A system that leaks sensitive data through error messages, debug output, or misconfigured APIs is vulnerable to in STRIDE. Encryption and access controls are the response.
Denial of service, the D, means disrupting availability, flooding a service, crashing a process, or exhausting a resource. That maps directly to the availability pillar of the CIA Triad.
Elevation of privilege, the E, is when an attacker gains access levels beyond what was granted, like a standard user running code as administrator. Think of it like a guest with a room key who somehow ends up behind the front desk.
For the exam, Isabella, know which the CIA Triad property each STRIDE threat violates. Spoofing and repudiation attack authentication and integrity. Tampering attacks integrity. Information disclosure attacks confidentiality. Denial of service attacks availability. Elevation of privilege attacks authorization and integrity. Map these relationships cold and STRIDE, exam questions become straightforward.
PASTA is the second major methodology, and it thinks differently from STRIDE. Where STRIDE asks what category of threat exists, PASTA asks what the business actually risks. Think of it like an insurance company doing a home inspection. They are not just listing every possible hazard. They are connecting hazards to real financial exposure.
PAST A has 7 stages. You start with business objectives, understanding what the organization is protecting and why. You move through technical scope, application decomposition using data flow diagrams and trust zones, threat identification, vulnerability identification, attack modeling, and finally risk and impact analysis.
Stage 3 is where PASTA intersects with data flow diagrams, which we cover in Scene 5. The decomposition step is what separates PASTA from Active Directory hawk guessing. You are systematically mapping your attack surface before you ever identify a single threat.
The bottom line on PASTA: it is risk-centric, it quantifies business impact, and it bridges the gap between security teams and executive stakeholders. If Stride is the engineer's tool, PASTA is the tool you bring to the boardroom.
Liam nailed it. The decomposition step is where theory becomes rigor. Stages 4 through 7 layer in the attack simulation. You identify threat agents, map them to vulnerabilities, simulate attack scenarios, and score residual risk and business impact. The output is a prioritized risk register, not just a list of threats.
VAST takes a different angle entirely. Visual, agile, and simple threat modeling was built for DevOps teams running continuous delivery pipelines. Traditional threat modeling assumes you sit down for a week-long design review. VAST assumes you have a 2-week sprint and security needs to fit in automatically, at scale.
VAST has 2 model types: application threat models for developers and operational threat models for infrastructure teams. It integrates with CI/CD pipelines and produces outputs that developers can action immediately, not 60-page reports that get filed and forgotten. Wait until we get to the software development lifecycle scene. That is where VAST really shines.
For exam purposes, know the key differentiators. Stride is category-based and engineer-facing. PASTA is risk-quantified and business-aligned. VAST is agile native and pipeline integrated. The exam often presents a scenario and asks which methodology best fits. Map the scenario to those differentiators.
Here is a thought experiment. If you wanted to steal the crown jewels of a financial institution, how many distinct paths exist? 50, 200. Attack trees, introduced by Bruce Schneier in 1999, give you a systematic way to enumerate every single one before an attacker does.
The model starts with a root node representing the attacker's ultimate goal, then branches outward into every possible sub-goal needed to achieve it. The tree makes your entire attack surface visible at a glance, not as a list, but as a structured graph.
Picture a real tree. The trunk is the attacker's ultimate objective, and every branch is a different route to get there. End nodes require all child conditions to be met, or nodes mean any one path is enough. An end node for gain admin access might require both a phished credential and a privilege escalation exploit working together.
The power of attack trees is in cost analysis. Each leaf node can be assigned a probability, a cost to the attacker, and a cost to defend. Add those up and you instantly see which branches are most likely, most damaging, and cheapest to cut off. Defenders should cut the cheap branches first.
Michael's tree analogy connects directly to risk management. And nodes are exactly how we framed defense in depth back in the risk control episodes. All links in a chain must hold. Break anyone in node and the attack fails. This is the design philosophy behind the Lockheed Martin cyber kill chain.
The Cyber Kill Chain, published by Lockheed Martin in 2011, describes 7 sequential phases of a targeted attack: reconnaissance, weaponization, delivery, exploitation, installation, command and control, and actions on objectives. Every advanced persistent threat follows some version of this sequence.
Here is the defender insight from the kill chain model. The later in the chain you detect an attacker, the more damage they have already done and the more expensive remediation becomes. Catching at reconnaissance costs almost nothing. Catching at actions on objectives means you are in incident response mode, with full breach disclosure.
The defender strategy is simple: detect and disrupt at the earliest phase possible. This is why threat intelligence email filtering, and network segmentation matter, they collapse the kill chain before exploitation even occurs.
For the exam, attack trees are graphical hierarchical models for systematically enumerating attack paths. The kill chain is a linear sequential model of adversary behavior. Both are tools for anticipating attacker logic, which is exactly what threat modeling is for. Know which situations call for which tool.
Data flow diagrams, or DFD, are the foundational artifact of threat modeling. Before you can identify threats, you need to know what you are protecting and how it moves. A DFD gives every stakeholder, developer, architect, CISO, the same visual language to reason about the system.
Think of a DFD like a plumbing schematic. Processes are the valves and pumps that transform data. They are the circles on your diagram.
Data stores are the tanks where data rests: databases, file systems, message queues. They appear as two parallel lines on the diagram.
External entities are the actors outside your system boundary: customers, third-party APIs, payment processors. They are the source and destination of data that you do not fully control.
The arrows connecting everything are the data flows. They show exactly what data moves, in which direction, and between which components. Every arrow is a potential attack vector.
The critical element that the CISSP exam emphasizes is the trust boundary, shown as a dashed line. A trust boundary marks where the privilege level changes, from internet to web tier, from web tier to database tier.
Every crossing of a trust boundary is an automatic flag for a stride analysis. What spoofing could happen here? What tampering? What information disclosure? Isabella said it best. The DFD becomes a threat generation engine, not just a documentation artifact. That shift in mindset is exactly what the exam is testing.
In real enterprise environments, trust boundaries are the single most overlooked element in system design. Teams document processes and data stores religiously, but leave trust boundaries implicit. An implicit trust boundary is an unexamined attack surface.
The practical rule: draw your DFD first, draw every trust boundary, then apply stride at every crossing. That sequence is exactly how the Microsoft threat modeling tool works and what the exam expects you to know.
The bottom line: if your DFD has no trust boundaries, it is incomplete. Every real system has at least three: the internet perimeter, the application tier boundary, and the database tier boundary. Candidates who miss trust boundaries almost always pick the wrong countermeasure.
Drop in the comments, how many distinct trust boundaries does the most complex system at your organization have? Most security engineers undercount by at least half.
The question of when to threat model has a clear answer: as early in the software development lifecycle as possible. The design phase is the last point where architectural decisions are cheap to change. Once you have committed to a microservices architecture or a specific API design, changing a trust boundary decision costs weeks of refactoring.
In a traditional waterfall software development life cycle, threat modeling slots into requirements gathering and system design. You build your DFD during design, apply stride at every trust boundary crossing, and generate a security requirements list that feeds directly into the implementation phase. That output is your misuse case catalog.
In Agile and DevSecOps environments, threat modeling cannot be a waterfall-style annual exercise, and this is where VAST comes back. VAST was specifically designed to integrate with sprint cycles and CI/CD pipelines. Teams produce lightweight threat models per feature, not per product, and the tooling flags new trust boundary crossings automatically.
The three outputs of a good threat modeling session are a risk register of identified threats prioritized by likelihood and impact, a set of security requirements derived from those threats, and a misuse case library. Misuse cases are the dark mirror of use cases. They describe how the system can be abused.
The real-world anchor here is Microsoft's security development lifecycle, which has mandated threat modeling for all Microsoft products since 2004. The Microsoft Threat Modeling tool, which implements Stride, is freely available. Fortune 500 companies using Azure are often required to produce DFDs with trust boundaries as part of their enterprise architecture review process.
Now for the exam trap, and candidates often see this framing. The exam may suggest that threat modeling only applies to new systems or greenfield development. That is wrong. Threat modeling applies to existing systems whenever significant changes occur. New features, new third-party integrations, infrastructure migrations, or after a security incident.
If you take nothing else from this scene, threat model before you build. Every methodology we covered exists to move threat discovery left in the development lifecycle.
The cost of discovery at design is roughly 1/10 the cost of discovery in production. That single data point is why executives fund threat modeling programs and why the CISSP exam tests it.
We have covered a lot of ground today. 6 distinct threat modeling frameworks and techniques, all rooted in Domain 1's risk management foundation. The cross-domain connections here are worth keeping in mind. These tools appear in software security questions in Domain 8 as well.
Let us run the recap. Stride gives you 6 threat categories that map directly to the CIA triad failures. PASTA gives you a 7-stage business-aligned risk quantification process.
VAST gives you the Agile native version that fits sprint cycles, and CICD pipelines the tool you reach for when your team ships every 2 weeks and cannot afford a week-long design review.
Attack trees let you enumerate every possible attack path to a goal, assign costs and probabilities, and prioritize defenses graphically.
The cyber kill chain maps the 7 sequential phases an attacker follows, and the defender insight is that earlier detection means cheaper remediation every time.
Data flow diagrams and trust boundaries are the artifact that makes everything else work. No DFD means no visible attack surface, and no trust boundary means no systematic stride analysis.
Drop in the comments which threat modeling methodology does your team use, and where in the software development lifecycle does it actually happen. The gap between what organizations say they do and what they actually do is often telling.
If you forget everything else from today, remember this one. Model threats before you build. Every methodology we covered exists to move threat discovery left in the development lifecycle. Subscribe so you do not miss Topic 112, Supply Chain Risk Management.
All right, quiz time. Let's find out what's stuck. Think through each question carefully before you answer.
Every subscriber helps us justify making more of these. Smash subscribe and let us keep going.
Which Stride threat category maps most directly to a failure of non-repudiation? The correct answer is D, repudiation.
A security team is using a methodology that maps threats to business impact and produces a quantified risk register after 7 structured stages. Which threat modeling methodology are they using? The correct answer is D, PASTA.
On a data flow diagram, which element represents the point where data moves between zones of different trust levels? The correct answer is C, trust boundary.
Good work on the quiz. Let us close the loop on threat modeling. We started by asking how to find security flaws before attackers do, and every technique we covered today is an answer to that question from a different angle.
Stride categorizes the threat. PASTA quantifies the business risk. VAST fits the methodology to your development pace. Attack trees enumerate every path to the attacker's goal. The kill chain maps defender intervention points. And the DFD with trust boundaries is the artifact that makes all of it concrete and actionable.
the simplest way to remember all of it. Draw your system, mark where trust changes, then ask stride at every crossing. That one habit covers more ground than any single methodology alone.
Think of threat modeling as the architectural review you wish every major breach had included. Most of the high-profile incidents we see were avoidable if someone had drawn a DFD and asked what can go wrong at this trust boundary before going to production.
Next up is Topic 112, Supply Chain Risk Management. Hardware Trojans, compromised software packages, and SBOM requirements. Watch the next video to see how threat modeling feeds directly into supply chain risk identification.
Keep connecting the dots. See you next time.
That was a strong episode, Liam. The students are in good hands. Professor Erica, signing off.